All right, guys, welcome back. Today, our title is One Step Equations. If I didn't mention this last time, I just want to be clear that this is going in your math spiral. I would use front and back of your pages. It'll make your math spiral last longer. And then I would start either a new section, like draw a line, make a new section, or a new page for this. But please utilize the back sides of your paper also. So your title for today is One-Step Equations. Again, I would go ahead and pause and write down what's on the screen, and then when you're ready, unpause and we'll talk about it. So we have two fill in the blanks here, and blank is in a mathematical statement that two expressions are equal. Okay, this key word here is equal, and our missing word is an equation. Okay, equation, its prefix or its root word is essentially equal. Okay, an equation means that two things are equal, which is why it's so important that when we do things to one side, we have to do them to the other. So a blank is a value of a variable that makes the equation true. So this is a solution. So when we're solving for a variable, like we're solving for x, let's say x equals 2. What that means is if I plug 2 back in, both of my sides should end up equal. Okay? That's what solutions are, if you haven't been told before. So we're going to work on one steps today. Again, I hope you've seen one steps before. I hope you're good at one steps. We have to start at the bottom and work our way up. So a one-step equation is the simplest. Now I know that this means that some students don't feel the need to show their work because it's only one step and it's so easy. But we're going to get up to 3, 4, sometimes 5 steps. So I need you to practice now on the easy ones, showing your work, so that when we get to the harder ones, you know what you're doing. So I know it might seem silly that I'm requiring you and asking you to show your work now, but it'll pay off later if you just trust me. So I also know with one step, sometimes it's really easy to guess and check. Like blank plus 10 equals 13, oh, x is 3. But I still want to strongly caution you against doing that because we're going to add more steps and it's going to get increasingly harder to guess. So I need you to work the process now so that it's easier for you later. So here, our first example is x plus 10 equals 13. I like to draw this line down the center because, as I mentioned, whatever we do to one side, we have to do to the other because it's a scale and it's balanced. If I add 2 on this side, it's heavier and now they're not balanced. I have to add 2 to both sides to make them balance. I think the line helps you see where your two sides are. The line is not required. Showing your work is required. But I do think the line is a useful tool. So here, I have to do the opposite to move this 10. So to get rid of 10, I have to do the opposite and subtract 10 from both sides. So my x comes down. This is gone because it is now 0. 10 minus 10 is 0. We don't need to write 0. 13 minus 10 is 3. And that's how we're going to show and prove that that's 3. So I know that you could probably guess that it's 3. But again, we're starting with easy problems so that we can learn the process when we get to the hard ones. So here, next example, n plus 3/8 equals 5/8. So I have to do the opposite and subtract 3/8 from both sides. Now, you can use your calculator, but this is a pretty simple fraction problem. 5/8 minus 3/8 is 2/8, which is the same as 1/4. And I do need 1/4 to be your final answer. If you can simplify a fraction, you need to. And if you put this in your calculator, it'll simplify it for you automatically. But again, fractions are okay. They shouldn't be this big, scary thing. So I do expect you to be able to do this without a calculator. 2.5 equals x minus 5.7. So again, I think that line is very helpful. I have to do the opposite to move this away from x. So I'm going to add 5.7 to both sides. So that one's gone. And then let's go ahead and add. We would have 8.2 Again, decimals sometimes freak people out. They're fine to use. Having a decimal answer is fine. Having a fraction answer is fine. Having an answer of 0 is fine. And if you need to, you can use a calculator. But often students are faster if they know how to do it without a calculator. And then there's always a chance that you type it in wrong and then you have no idea that your answer doesn't make sense. So just something to think about. Try not to rely on a calculator, but you're welcome to use one in general. So here, this goes back to our integer operations we were talking about yesterday. Subtracting a negative is the same as adding a positive. So I'm going to rewrite that first thing, because then it's easier to deal with. And then I'm going to do the opposite. The opposite of adding 3 is subtracting 3. Here, they're both negative, same sign, sum. So -8 is our solution. Okay, some more one steps. So I'm going to draw my line down. Whenever a number and a variable are right next to each other like this, that means they're being multiplied together. They don't put the multiplication sign in between there, but that is what it means. So this is the same as 9 times y. Okay, they just didn't put the multiplication symbol there. We're supposed to know and learn that these two right next to each other mean multiplication. So the opposite is division. And I like to use a fraction bar for division so that it's right underneath. Fractions are the same as dividing something. So here, 108 divided by 9, I believe, is 12. Normally I would say correct me if I'm wrong, but you can't do that right now. But I'm pretty confident in that. All right, draw our line down. Like I was mentioning over here, fraction bars are the same as division. So this is the same as x divided by 3. But once we're in algebra, we start to use a fraction bar instead. Just like once we're in algebra, we stop writing that multiplication sign. So the opposite of dividing by 3 would be multiplying by 3. So now x is over here. 3 times -8 is -24. Also, one more note, if you aren't already, you need to start using a dot for multiplication if you haven't already, because now that we have variables like x, we don't want to confuse them with the times symbol. So if you use an x for times, let's get out of that habit now and start using a dot for multiplication. 5/9 n equals 35. So I'm not sure if you remember or not, but you cannot divide by a fraction. Getting rid of a fraction means you have to multiply by the reciprocal. The reciprocal is that fraction flipped upside down. So multiply by the reciprocal. The reason this works is because these create 1. 9/5 times 5/9 is equal to 1. That's why we're doing that. So n, and I have to do it to both sides. Gotta take my own advice. And you are welcome to use a calculator. I'm going to cross simplify here. Looks like our answer would be 63. And you can check me on a calculator with that if you want. But again, I'm pretty confident that it's 63. All right, another fraction. So to get rid of 1/5, we have to multiply by the reciprocal, 5/1. And 5/1 is the same as 5. So this would be -5/4. Now this negative is kind of in the center. You can move it to the top or move it to the bottom or leave it in the center. All of those are fine. So like -1/4 written like this, or where it's right in the middle are all the same. Okay, this does not mean both numbers are negative. Just one of the digits is negative. Okay, 4/6 n equals 2/3. So the n is on the top, but it's the same if you want to rewrite it as the n being on the side. So that's another thing where those are the same. To get rid of a fraction, I'm going to multiply by the reciprocal. So you can multiply straight across, you can cross simplify, or use a calculator, whatever you are comfortable with. But it looks like we're going to end up with 2 over 2, which is the same as 1, or if you didn't cross simplify, 12 over 12, which is still the same as 1. Negative n over 5 equals 10. So again, this negative is right in the middle. I'm going to go ahead and put it with the 5 because I want a positive n in my solution. So to get rid of it, I'm going to multiply by negative 5 on both sides. So this is n equals negative 50. And again, I know I go quick. I just expect you to pause whenever you need to. Last problem for today. Nico puts 1/4 of the money he earns from mowing lawns into a college education fund. This year, Nico added $285 to his fund. How much money did Nico make mowing lawns this year? So just a quick note, your answer should always make sense. So before we even start, our answer should be a lot bigger than this 285 because he has to make more money than he puts into his fund. So that's always a good thing to check. But it says he puts 1/4 of the money, so the fraction 1/4 of however much he made. We don't know how much he made, so that's why we're going to use the variable. He puts into his education fund. And this year, that was $285. So we need to figure out how much did he make. So to get rid of that 1/4, I'm going to multiply by the reciprocal, 4 over 1, or just 4, if you want to think of it that way. 285 times 4. I am going to use a calculator for this one. Is 1,140. So over the summer, he made $1,140. And that makes sense because that's 4 times as much as he put in his account. But if I somehow ended up with a smaller number, like let's say I accidentally divided 285 divided by 4, let's say I got $71.25. That wouldn't make any sense. How can he put in more money than he made? So those are things to keep in mind when you're doing word problems. This is the end of your video notes, and now you're moving on to a book assignment on big ideas. So the link is in our module on Canvas, and there's also a big ideas link. Both should take you to your assignment for today. It is called 1.1 practice.